Welcome. I will continue estimation. In last class, we could cover the confidence interval of single population mean and confidence interval for single population variance, confidence interval for the difference between two population means and confidence interval for the ratio of two population means, ratio of two population variances. This is not covered, and now within 20 minutes of time we will try to cover these two concepts, that confidence interval for the difference between two population means and ratio of two population variances. So, if I quickly recapitulate what we have discussed from the confidence interval point of view, with reference to a single population means, I said that the quantity y bar minus mu by sigma by root n, this follows z distribution. So, when it will be z and t, those kind of discussions I have already made. You see the first few slides of my previous lecture, you will know. And we say that you will create a interval which is known as low and low limit and high limit. With reference to the normal distribution, this will be plus z alpha by 2 and this will be minus z alpha by 2, where alpha by 2 is the area under the curve right to this point, upper point limit. Similarly, this one is also alpha by 2, which is left to the lower limit, and there is the mean of this quantity as it is normally distributed, unit normal and 0 1. So, this value is 0. Our sole purpose is basically to find out what is the interval of the different estimation. So, accordingly we have created the probability low less than equal to y bar minus mu by sigma by root n less than equal to u, and this is 1 by alpha, and accordingly this L and for z distribution L and u are replaced by minus z alpha by 2 less than equal to y bar minus mu sigma by root n and plus z alpha by 2. This is 1 by 1 minus alpha, and our confidence interval is this. This we have computed, and you got the interval for mu. Okay. No longer we have one population, we have two different populations. So, two population. Okay. So, two populations case, population 1, suppose the variable of interest is y 1 and its mean is mu 1 and variance is sigma 1 square, and you have collected n 1 data points. Population 2, variable of interest y 2, mean is mu 2 and your this one is sigma 2 square variance, and you collected data mu 2. Okay. So, what we want basically, there is the slight difference is there. The variable of interest is same y for the two population point of view, but as population 1 is having certain distribution with this and population 2 with this, fine. So, you collected two different sample of size n 1 and n 2, and these sample are independent samples. Okay. Now, you from the sample we are denoting that sample 1 from population 1 and sample 2 from population 2. So, sample 1 point estimation is y 1 bar, sample 2 point estimation is y 2 bar from mean point of view, from standard deviation point of view or variance point of view S 1 square and S 2 square. Okay. So, S 1 square and S 2 square, fine. So, what is our objective here? We want to find the confidence interval for mu 1 minus mu 2, Ci for mu 1 minus mu 2. So, what is mu 1? Mu 1 is the population mean for the variable of interest y, and mu 2 is from population 1, mu 2 is for population 2. Okay. So, what is the then sample equivalence? Definitely y 1 bar minus y 2 bar. So, you collect a sample from first population and another one from second population, compute this, you are getting this. You repeat this process, you will be getting several such y 1 bar minus y 2 bar values. So, y 1 bar y 2 bar is the random variable of interest, y 1 bar minus y 2 bar. Okay. So, what do you require now? You require to know what is the expected value of y 1 bar minus y 2 bar. This will be expected value of y 1 bar minus expected value of y 2 bar, and this will be mu 1 minus mu 2. You know this, earlier we have discussed. Similarly, variance of y 1 bar minus y 2 bar is important. Here this will be variance of y 1 bar plus variance of y 2 bar, and why this, you know, I have explained earlier, and there is no covariance part because the two samples are collected from two different population and they are independent in nature. So, this will be sigma 1 square by n 1 plus sigma 2 square by n 2. Okay. Now, we will create a statistic here. That statistics is y 1 bar y 2 bar, that is the random variable, minus its expected value y 1 bar minus y 2 bar by its variance y 1 bar minus y 2 bar. This is nothing but y 1 bar minus y 2 bar minus mu 1 minus mu 2 divided by sigma 1 square by n 1 plus sigma 2 square by n 2. Okay. So, this is the statistic. So, what will be its distribution? If sigma 1 and sigma 2 known and coming from the normal population, then we can assume that this will be Z distribution, unit normal distribution. So, in that case, we can write this, that probability L, we are interested to know probability L less than equal to y 1 bar minus y 2 bar minus mu 1 minus mu 2 divided by sigma 1 square by n 1 plus sigma 2 square by n 2 u equal to 1 minus alpha. That is of interest. So, we want this. So, essentially what you require? You require L and U. So, if you see the last class first to second or third slides, where we have given that when you go for T and you Z distribution. So, depending on this, suppose it can be T, it can be Z distributed. If it is, suppose if this is Z distributed, then already I have explained this, minus Z alpha by 2 plus Z alpha by 2. If it is T distribution, then this will be minus T n minus minus T, its degrees of freedom, suppose D I write, let me write alpha by 2, and this side plus T, D is DOF, degree of freedom into alpha by 2. So, this is L here, this is U here, and for Z this one is L and this one is U. So, what you do, confidence interval, when you try to find out y 1 bar minus y 2 bar minus mu 1 minus mu 2 divided by sigma 1 square by n 1 plus sigma 2 square by n 2, then this less than equal to, you write minus Z alpha by 2 plus Z alpha by 2, or you write T minus T alpha by 2 DOF less than equal to this quantity less than equal to plus T DOF alpha by 2. Okay. So, you have to understand that what is the what is your I can say that situation, whether it is T or Z situation accordingly. So, ultimately what happened, you just see the some of the slide, the concept is given to you. Now, what happened, you see that if it is z distribution, this is the equation, and from this you can very easily come to this equation, y1 bar minus y2 bar minus z alpha by 2 into this variance part, and this will be this. For normal population with known sigma 1 sigma 2, for non-normal population with known sigma 1 sigma 2, but for large sample size. The situation when it will be used, you use this formula for computation of confidence interval for difference between two population means, it is that for all normal population when sigma 1 and sigma 2 the variances are known, for all other population when variance sigma 1 square sigma 2 square standard deviation is are known and large sample size you have taken into consideration. Okay. So, what will happen okay, one example is given here. So, the example is we have chosen two filter type 1 and filter type 2. So, filter is a factor, it has two levels, one is filter type 1 and type 2, and you have run the experiment 12 times using filter type 1 and 12 times using filter type 2, obviously randomized design. It is not that the in sequence only with filter type 1. So, then what is required to know? We are interested to know what is the 95% confidence interval for the difference between two population means. That means the response time, that level at detection, signal at level at detection, whether they are different if we use different filter types. Okay. So, essentially what I mean to say, you have conducted experiment, that is the radar scope experiment, So, your y variable of interest is signal level at detection. So, here your two populations are two levels of that filter type 1 is one first population, filter type 2 is second population. Please remember, this is nothing but the two levels of, these are the two levels, level 1 and level 2, of filter type. When I explained the experiment in first few lectures, we explained that there are two levels, and that's so that means factor levels are treated as population. Okay. So, otherwise I can say that you are doing the experiment with type 1 filter and type 2 filter. This is level 1, this is when you are doing experiment, whatever result you are getting, that is from, we are saying that from population 1, whatever result you are getting, that coming from population 2. So, that means these 12 observations here. So, N1 equal to 12 observations, again N2 equal to 12 observations here you have collected. In your sole interest to see that whether the mean y mean will differ for the two or not. Important, because when your factor has two levels, you can do this. Okay. So, now then what we have computed? We have computed mean y for population 1, that is filter type 1 and filter type 2, and the variance 6.5 and 5.5, is it given? Yes, 6.5 and 5.5 standard deviation, which is the square root of variance, is given. Okay. N1 equal to N2 equal to 12, and you have used mean this random variable minus z into the variance component, standard deviation, and then this plus z and standard deviation part. So, the resultant quantity 8.37, this will be this is mu in the sense, it is basically we try to write theta, that is mu 1 minus mu 2. So, 8.37 to 16.63, That means the confidence interval 95% confidence interval of mu 1 minus mu 2 in this case is 8.37 to 16.63. Okay. So, what is your interpretation? Interpretation is that what is the point estimate y 1 bar minus y 2 bar 101.58 minus 89.08. So, this value is 0, then 5, then this is 92891. So, 12.50. So, if you go by 12.5, then if I write this side that this is my y 1 bar, the difference between two population means. So, y 1 bar minus y 2 bar, this is the axis, point estimate somewhere here 12.50 and interval estimate will be 8.37 to 16, this is 16.63 and this is 8.37. So, 95% of the data will fall under this. So, this is my distribution and 95% of the data points will be within this range. Okay. So, when you take decision, you also should consider that it can be as low as this, as high as this, but average value is this. This is the decision. Now, go for the second one. Confidence interval between two population means the special case, very important one. Most of the time we assume that the two population variances are equal, that means sigma 1 square equal to sigma 2 square equal to sigma square. So, what I say, we are saying that whether you use type 1 filter or type 2 filter, in the Radarscope experiment, the mean value will differ, but the standard deviation will not differ. So, it may not be a correct assumption for this case, but many a time we will consider this and it is also true. So, when you know, that means sigma, your things are becoming little better, because when you calculate the population variance for the mean from filter 1 or filter 2, you take the data point, when the difference you take these two. So, now what happened? Okay, for the time being you think like this, that this is equal sigma square. Later this other concept what I supposed to tell you, I will not tell now, I will tell later on, because it requires something more. So, under such situation what we will do? We will use that the variance part is like this, that means variance of y 1 bar minus y 2 bar is this. So, then it will be what? Sigma 1 square sigma square into 1 by n 1 plus 1 by n 2, correct. So, suppose what happens that you do not know the sigma square, this sigma square is not known, sigma not known. If sigma is known, sample size is large, or sigma known and coming from normal population, your Z distribution fantastic, no problem. Suppose sigma equal but not known, under this situation you can find out the sigma, estimate the sigma not from one population or from only data from type 1 filter or data for type 2 filter, rather you mix them and get pooled variance. That is what I want to tell you. The pooled variance is very important, because if sigma 1 square equal to sigma 2 square equal to sigma square, and then you may expect that their sample variance will be equal, but that will never happen. So, it may happen, it will not happen actually. Now then, as this is the assumption and it is assumed to be true, so why can't we take all this n1 plus n2 observations together and calculate the variance, that is known as pooled variance. So, we will not merge them and then finally after if it is n1 plus n2 data points and we find out the S square using the formula. Rather we use a different formula which is known as SP square is the pooled variance. This is n1 minus 1 S1 square plus n2 minus 1 S2 square by n1 plus n2 minus 2. Okay. Now, this what you will do, that means your this value is known. Once this value is known, and as we know the sigma is not known, this is known, and many times the sample size will not be large also. So, whatever, but even if sample size is large, you will use t distribution, no difference, because for large sample size z and t distribution coincides. So, now see this slide. So, it is a t distribution case. So, you know that minus t alpha by 2, that is L, and here DOF u will be plus t alpha by 2 DOF. Now, what will be the DOF in this case? DOF in this case is n1 plus n2 minus 2. So, that is what is written here. What we have written? That our random variable of interest is the average difference y1 bar minus y2 bar, and we are interested to find out the confidence interval mu1 minus mu2. Now, this SP will be used in place of sigma, and SP is computed using this formula. So, it follows t distribution with n1 plus n2 minus 2 degrees of freedom, n1 plus n2 2 degrees of freedom. Okay. So, now see one example. Yes, example is given, that same example as the number of because here sigma 1 sigma 2 not known and the sample size is 12 per population, it is not a large sample also. And what we will do, we assume that the population variances are equal. Under such situation, we will use the formula what is given. What is this SP square formula? N1 minus 1 means 12 minus 1, it is 11 into the S1 square, 11 into S2 square by 12 plus 12 minus 2, that is 22. So, SP square is coming as 47.625. SP is square root of this. Now, the formula y1 bar minus y2 bar, that value is 1.56 minus t 20 n1 plus n2 minus 2, that is 22 alpha by 2 0.05. You see that in this is the t distribution table. So, degree of freedom is 22, alpha is 0.025 and the t value. So, what I mean to say that t n1 plus n2 minus 2 alpha by 2 equal to t 12 plus 12 minus 2 into 0.05 by 2, this is t 22 0.025, and from table you get this value is 2.07387. So, from the slide what you will see that t 22 0.025 equal to 2.07387, and you put this formula and you are getting this interval. Okay. So, it is coming minus. So, SP is this, and 1 by 1 minute formula 1 by n1 2 by 12 means 1 by 6, t is this value, y1 bar minus y2 bar, y1 bar minus y2 bar same example we have taken, y1 bar minus 12.56. Okay, so there is calculation mistake. I think it will be 12.53. Okay, 12.53 and it's 12.53. I think. Okay. Anyhow, so what I mean to say that you use this formula y1 bar minus y2 bar, and here y1 bar minus y2 bar is 12.5. So if I consider this formula, that 12.53 minus 2.07387 into SP value is our, what is our SP value? 6.901 into root over 2 by, and that is 1 by 12 plus 1 by 12, 2 by 12, this plus minus, this is the interval. Okay. So you calculate this. Now, now we will discuss another concept called confidence interval for the ratio of two population variances. So here we will use S1 square by sigma 1 square and S2 square by sigma 2 square. So this, because we are considering N1 minus that this quantity will statistics will create, and we will see that this can be written as N1 minus 1 S1 square by sigma 1 square into N1 minus 1 divided by N2 minus 1 S2 square by sigma 2 square into N2 minus 1. So this quantity is chi-square distribution, following chi-square distribution, this follows chi-square distribution divided by their respective degrees of freedom. So chi-square variable by degree of freedom by chi-square, another chi-square by degree of freedom, this will be F distribution, and with N1 minus 1, N2 minus 1, N1 minus 1 and N2 minus 1 degrees of freedom. Okay, so that means this quantity follows F distribution. So what you have data, what you want to know? You want to know the ratio. So you are interested to find out interval something like this. So you create, what you will do? Suppose, how would you create? You think that this is F distribution. So this one is alpha by 2. Here also you take another area alpha by 2. Then this is F N1 minus 1 N2 minus 1 alpha by 2, and this value will be F N1 minus 1 N2 minus 1 1 minus alpha by 2. So this is my low value, this is my upper value. So then what happened? S1 square by sigma 1 square and S2 square by sigma 2 square will lie in between F, this lower value, N1 minus 1, N2 minus 1, 1 minus alpha by 2, F alpha by 2, N1 minus 1, N2 minus 1. So and now you manipulate this and you will be getting this. This slide, that is slide S1 square by S2 square divided by F N1 plus minus 1 N2 minus 1 alpha by 2 sigma 1 square by sigma 2 and this. So this is the formula. Okay. Now see the, suppose the same example, filter type 1 and filter type 2, you want to construct the ratio of the variances. So that S1 square, what is the formula here? Formula is S1 square by S2 square. Okay, so S1 square by S2 square, this is 1.563. Then what is the F value? F value, what will be the F value? F value will be so F A, what is N1? N1 equal to 12, N2 equal to 12. So what you require? F of 11 and 1 minus 0.025, this value you find out, and another one f 11 0.025 you found out, and put there, put into these equations and then calculate this one. So, okay. So, just in order just to do this one, what is this that conclude that, please remember that you first required to know in the confidence interval, you required to know the random variable of interest. When it is single population, then the either mean or your standard variance will be variable of interest, and you create a statistic, particularly using the central limit theorem here, and here also the based on the distribution what it will follow, you create the statistic, find out the statistic, the appropriate probability distribution for this statistic. So, some many times z distribution, t distribution for y bar, chi-square, and for f distribution for variance. So, appropriate statistics here will be z dot t, here will be chi-square or f. Then you choose the significance level, usually we say it is alpha, and this will give you the lower limit and upper limit, and you choose in such a manner that L this statistics. So, it will be 1 minus alpha, and then put take from table, from appropriate table, find the lower value and upper value, put here, and you get the confidence interval. Okay. So, thank you very much. Chalo.